Good morning. Welcome. I stand before you with not one, but two introductions today. The first to help describe the occasion of this lecture. It's the Lindsay Breed Memorial Lecture. And the second to introduce our speaker. Lindsay Breed was a native of Marblehead, graduate of Wake Forest, studied communication, worked in business in the Boston area, was a student at Suffolk Law School when at the age of 30 died unexpectedly young. Lindsay was a member of the Vincent Club, an organization and long associated with and has long supported our department. And on the occasion of her what would have been her 31st birthday, friends, family, members of the Vincent Club gathered to raise money for a lecture in her honor that for the last 15 or so years has been held with the notion of bringing a distinguished speaker, maybe from a bit afar, to introduce a topic new, novel, not generally part of the OBGYN curriculum. And our speaker today is and will fulfill those missions terrifically. Before introducing him, I should recognize that a number of Lindsay's family, I am told, are joining us on Zoom today, and I want to welcome them back to our community and family. Dr. Eli Adashi is a distinguished OBGYN, distinguished academician, leader, clinician, began his career in Israel, one of the first graduates of Tel Aviv's medical school. Following his training there, made his way to Boston, undertook a residency in OBGYN at Tufts, followed by training in then the nascent field of reproductive endocrinology at both Hopkins and UCSD. His subsequent career included a tour at the University of Maryland, where he served as acting chair, time at the University of Utah as chair, and then back to the East Coast to Brown, where he was dean of the medical school for a great number of years, helping that institution grow in terms of its student body and its research portfolio. He continues as a professor at Brown Medical School and the Brown community now. His academic career has been broad, a lot of time and work in NIH funding focused on ovarian biology and the role of growth factors and cytokines in the biology of the ovary. Many of you know him. I know him most recently as someone who has really thought long and hard about bioethics, particularly related to reproductive technologies. Every Sunday in my email, I get a letter from Dr. Adashi with kind of this week's news and publications, and hardly a week goes by when there are, if not one, but several publications on a variety of topics related to the intersection of reproductive health, medicine, ethics, and law. Today, he's going to speak about something that many of you may not have heard of, but by the end of the day, your eyes will be wide and you'll be thinking about brave new worlds and where our field is going, in vitro gametogenesis. So with that, I will turn the podium over to Dr. Adashi. Please join me in welcoming Eli to speak with us today.
Thank you, Jeff, and thank you one and all for joining us this morning. I'm sort of at a loss for words after this introduction, as well as the realization that I began here approximately 50 years ago, which is unfathomable when I reflect on it today. But it's good to be here, and hopefully for still a long time to come. Last time I think I was here was when Isaac was the chair. Little did I realize that this became the Isaac Schiff Conference Center. I corresponded with him recently, hoping he might show up. He couldn't. He made no mention of the center, I might add. but I'm delighted to see all of that happening and more. Well, with that as a very brief introduction, let us delve into what Jeff appropriately identified as the future. This isn't here today, but the young members of the audience to whom I'm mostly addressing my comments today will be here to reap the fruits of these scientific developments that are currently maturing, as you will see, mostly abroad, but nevertheless, they will reach us before too long. In my view, it's just inevitable and just a question of time. This doesn't belong here, but it does show yours truly, approximately 50 years ago, as a fellow of Howard and Georgiana Jones at Johns Hopkins, alongside Doctors Zev Rosenwachs, now at Cornell, and John Rock, who happens to be in Saudi Arabia. As I mentioned to Jeff earlier, we wrote a paper in the American Journal of Medicine on the demise of in-person grand rounds and the triumph of virtuality, which is to say Zoom. And as we say in the paper, as much as we lament some of the loss that transpires when we no longer can shake each other's hand and really be in near proximity to our seniors and the like, Zoom has its upsides, and it definitely saved us during the COVID era. And so I don't exactly come down with a conclusion at the end of the paper, but you may, in the interest of pursuit, take a look at it. The origins of what we will be speaking about today cannot be discussed absent the backdrop of the introduction of IVF in 1978. Robert G. Edwards, PhD, received the Nobel Prize in Physiology and Medicine in 2010 for this accomplishment. For those of you who know some of that history, his collaborators, Dr. Steptoe and others, did not receive the Nobel Prize simply because, sadly, they were gone by that time. And it is the policy of the Nobel Committee not to award the prize to individuals who have passed away. I might also add that Dr. Edwards was hardly well at the time. And in fact, it was his wife who had to travel to Stockholm to receive the award on his behalf. Nevertheless, great credit goes to Dr. Edwards, Steptoe, and Purdy, who have made IVF a reality and are assisting an innumerable number of couples to achieve a pregnancy. It is estimated that anywhere from 12 to 15 million babies worldwide were born consequent to IVF. But today we will be speaking about the future, about in vitro gametogenesis, which is coming about just around 50 years since IVF first became a reality. The beginning is a little bit difficult to pinpoint, although I did inquire with the originator of in vitro gametogenesis, Dr. Mitinori Saito from Kyoto University, who indicated to me that this 2009 paper, in his view, may represent the beginning of this process. I began to notice in vitro gametogenesis early around 2010, 2012, and thereabouts. And in 2013, when I was in Japan for another reason, I booked a flight to Kyoto and met with Dr. Saito and Dr. Katsuhiko Hayashi, who is also an important piece of this combination, and spend the whole day learning and finding out about in vitro gametogenesis at a time when it was not all that well known around here. Needless to say, I was thoroughly impressed, and I remain so. As I mentioned, the two protagonists, and really almost the sole protagonists behind this story, are Professor Saito, who remains at Kyoto University, and Professor Hayashi, who in due course moved to Kyushu University, where he is today. At the time, though, they worked as a team and produced what, in my view, is just remarkable first-class science. The paradigms that they pursued, as you might imagine, were the rodent and the human, although primarily the rodent. We still have quite a bit to go when it comes to the human. And as is true of many fields of medicine, all of this is entirely contingent on so-called stem cells. In this case, pluripotent stem cells that come in two varieties, either embryonic or induced. And I will elaborate on that in just a minute. But the point is that pluripotent stem cells can become anything. They can become amacrine neurons in the retina. They can become dopaminergic neurons in the striatum. Think of Parkinson's disease. They can become motor neurons. Think of paralysis attributable to spinal injury. And I could go on and on. The point is that induced pluripotent stem cells, given the appropriate knowledge, can be guided into an endless number of fates, cellular fates, that could then serve particularly pathology, but also biology. And stem cell-derived gametes is just one biology or one pathology that we are going to be discussing today simply because this happens to be our line of work. For those of you who wish to get a bird's eye view of the subject, I recommend a science paper from 2021, wherein Professor Saito and Hayashi described the state of mammalian in vitro gametogenesis as it stood at the time. Not that much has changed since. The New England Journal of Medicine, not to be outdone, commissioned a paper from Mary Herbert and Nazim Surani from the United Kingdom titled Oocytes from Stem Cells. Not quite the same, but close enough. In 2023, I had the privilege of organizing a 2.5-day workshop that took place in Washington, D.C., under the auspices of the National Academy of Medicine. And in that conference, virtually anybody in the field spoke, most notably the Japanese investigators I mentioned earlier. To begin our conversation today, I would like to draw on this infographic, which the Nuffield Council on Bioethics, which you may know is the premier bioethical institute of the UK, a bioinformatic that they issue virtually every year. And it's interesting to note that in defining their agenda, which is what this is intended to achieve, in human reproduction, the first item on their list is in vitro gametogenesis, which is to say that our friends from across the ocean recognize, just as we do, that the future is probably in this particular topic. Now, they, of course, discuss time limits on maintaining embryos in culture, womb replacements, preconception screening, whole genome sequencing of embryos and fetuses, genome editing of gametes and embryos, and egg freezing. But at the top of the list, they have in vitro gametogenesis. I think we can all agree, and you will hopefully by the end of this presentation, that in vitro gametogenesis is a disruptive technology. It's still not entirely clear whether it's achievable in the human, nor is it clear what timeline we are struggling with. But it all brings us back to 1932 and Brave New World, authored by Aldous Huxley, wherein he made several predictions. He predicted that eggs will be produced via ex vivo ovarian cultures, not too far from the truth. That embryos will be produced via in vitro fertilization. And of course, he was right on. We're talking 1932. And he proposed that newborns will be born via ex vivo ectogenesis. We're not quite there yet. We're working on it. It's not clear that women will vote for it, but it's a possibility that children will not be carried in a womb, but will actually be delivered in a more mechanical, shall we say, technical fashion. Of all of these predictions, really the only one that was right on was IVF, but we're not that far off when it comes to IVG. To read from a quote in Brave New World, the director of hatching and conditioning, as he or she is referred to, says, one egg, one embryo, one adult, normality, making 96 human beings grow where only one grew before, progress. Now, when we use 96 well plates all over the place, it's highly typical to see 96 well plates with eggs, or perhaps even with embryos. But now let's direct or redirect our attention to in vitro gametogenesis and describe some of the early obstacles, which were mostly theoretical. Leave aside the technical challenges. And the theoretical obstacle was known as the soma germline barrier hypothesis, which most of us really haven't known about, but which was formulated by August Weismann from the University of Freiburg quite some time ago in his book, The Germplasm, A Theory of Heredity. In that 1893 book, Professor Weismann maintained that the germline gives indeed rise to the soma, and that by dint of that, the germline could be deemed immortal. He also proposed that the soma never gives rise to the germline, and by dint of that, must be viewed as mortal. IVG turns all of this on its head, because we now know that we can take a skin cell and convert it into an egg or a sperm, depending on whom we derive the sample from. So pluripotent stem cell formation technologies are now clearly coming our way, and invariably they relate or derive or draw on or depend on stem cells. Now, somatic cell nuclear transfer was a very early technology from 1958 that was introduced by John Garden from Cambridge University, who published a paper in Nature using frogs titled Sexually Mature Individuals of Xenopus laevis from the Transplantation of Single Somatic Nuclei. He began his creation of stem cell by enucleating a somatic cell, transfecting it with an oocytic cytoplast, and creating what amounted to a zygote that could then be taken all the way to an inner cell mass of an embryo. And from there, he derived what we now call embryonic stem cells, but rarely use because we have a simpler way of going about it. And the simpler way was designed in 2006. It's the so-called induction method, courtesy of Shinya Yamanaka, MD, PhD, also from Kyoto University, who published his paper in 2006 under the title Induction of Pluripotent Stem Cells for Mouse Embryonic and Adult Fibroblast Cultures by Defined Factors. What he did was far more practical. He started with a somatic cell, transfected it with a select number of transcription factors, and voila, he ended up with induced pluripotent stem cells, which are currently the workhorse of in vitro gametogenesis, but I might add, may also be injected before too long, and that's a separate conversation, into IVF. Because we no longer perhaps need to stimulate women for 12 days or more, because we can potentially create some of the cellular elements involved, both the oogonia and the stem cell, the surrounding cells, the granulosa and the theca, can all be created now through this technology. And so you'll be hearing plenty about induced pluripotent stem cells. They're going to be everywhere, and they are also the workhorse of in vitro gametogenesis. Not surprisingly, both Dr. Yamanaka and Garden received the 2012 Nobel Prize in Physiology and Medicine. So in vitro gametogenesis involves taking a somatic cell, let's say a skin cell, converting it to either an embryonic or induced pluripotent stem cell, and then guiding that stem cell towards a gametogenic fate. Sounds simple, but now is probably increasingly achievable. The prerequisites for such a process, of course, requires that we know the cues that we need to apply, the sequence by which we apply them, the timing thereof, and the niche in which they are encased. After all, nothing happens in the ovary or the testis without the somatic cells that surround the germ cells, the granulosa and the theca in the ovary, and the Sertoli cells in the testes. Which brings us to the beginning, which perhaps can be traced back to 2003 and a paper from the University of Pennsylvania, senior authored by then postdoc Hans Schöller, who produced oocytes from mouse embryonic stem cells, a sample of which is shown on the right lower hand side of this slide. That same year, Toshiaki Noche from Japan reported on the pages of the Proceedings of the National Academy of Sciences some of the same findings. Dr. George Daly, who is now the Dean of your medical school, published a paper, Derivation of Embryonic Germ Cells and Male Gametes from Embryonic Stem Cells in Nature, back in 2004. And so he's also was involved, to the degree that he's still active, is involved in this field. And Renee Rejo-Pera, who at the time was at UCSF, published in Human Molecular Genetics a similar finding. As we go through the first decade, if you will, of this century, you can see papers coming out intermittently in Nature and Science and Cell that deal with just the subject matter that we are tackling today. And later on, all the way through 2015, again, much of the same, not always the same actors, but sometimes the same. And so as we finally arrive at about 2015, we can say that the germ cell specification pathway is definitely not conserved between the rodent and the human. And so we need to work on them separately. And that the genetic networks involved are also quite distinct as well. So let's just say we've got our work cut out for us. There's a lot of science that needs to be covered before we are in the clear, but we have at least a sense of what we now need to do. So as we look at where we were in 2015, we can say that we knew how to convert embryonic stem cells or induced pluripotent stem cells into so-called primordial germ cell-like cells. But we didn't know how to go beyond that and to produce what we really want, which is haploid post-meiotic mature gametes. In a word, we mastered the extragonadal piece, but we had yet to master the intragonadal counterpart. The final frontier, of course, was in vitro gametogenesis all the way. Step in Katsuhiko Hayashi from Kyushu University, who in a Nature paper in 2016 titled Reconstitution in Vitro of the Entire Cycle of the Mouse Female Germline, has finally shown us how to do it, at least in the rodent. He started with stem cells, combined them with some somatic cells, produced the primary oocyte, mature M2 oocyte as shown on the left-hand side, went on to a fertilized egg, which created blastocysts, and voila, he produced pups. We're starting with embryonic stem cells, we're ending up with pups. Not to be outdone, Professor Saito did some of the same, albeit on the male side. And as you can see, the title of the paper is In Vitro Reconstitution of the Whole Male Germ Cell Development from Mouse Pluripotent Stem Cells. So we know how to do it in the rodent. But the human paradigm is somewhat of a different story. Professor Saito, in the most advanced paper in this arena, published in 2018, reported an effort to proceed from primordial germ cell-like cells all the way to M2 oocytes. But as far as we are concerned, he got as far as the oogonial stage. We have yet to figure out how to produce M2 oocytes that are fertilizable and that can give rise to potential clinical applications. Same is true on the male side, that remains to be brought to, shall we say, full circle. The human in vitro gametogenesis, which requires M2 oocytes and spermatozoa, are still in the works. But there is, and I think it's important to consider it now, a significant scientific and translational process here. For one, it will give us an inexhaustible supply of germ cells. It will allow us to perform so-called functional or null mutant analysis, that is to say, knock out certain genes and ask, what does that do to the biology? We could study germ somatic cell interactions, which currently we are limited about. And from a clinical point of view, we could potentially reverse germ cell failure. we could begin to dream about autologous gamete replacement, maybe gene-edited gamete replacement. What if you're dealing with a Turner patient? And we could perhaps begin to entertain, and that's a separate lecture I give, same-sex parenthood, if you can believe that. But we now know and have demonstrated and have published papers on same-sex parenthood. By that I mean genetic parenthood, all of which was, of course, impossible before IVG. Now, what impact IVG will have on IVF is that it will eliminate the need in stimulation and egg retrieval, which is beginning to percolate, I think, in the community. We just concluded writing a paper on the role of induced pluripotent stem cells in IVF, partly because a commercial company in the Silicon Valley just applied to the FDA to receive permission to proceed with clinical trials. In other words, when you see a company applying to the FDA for clinical trials, the writing is on the wall. And it's not going to be tomorrow. It may not be a decade before we see it happen, but it's unfolding. And so I think we need to consider the, I think, very significant likelihood that IVG will simplify IVF because it will spare women the prolonged stimulation, not the egg retrieval, but definitely the stimulation. You still need to replace the embryo, etc. But instead of a 12, 15-day, a far more streamlined effort. It will also do away with gamete donation, which we say is age dependent, but egg banks and sperm banks may well become history. And it will convert IVF largely, not entirely, to a laboratory procedure. And yes, it will require still, as I said, endometrial preparation and transfer, and may, just may, improve affordability. Having observed the American genius in jacking up prices, I sometimes wonder whether such predictions are practical. Even though we will be cutting our efforts in half or more, whether or not this will translate into a reduced price, time will tell. Whatever we do, it will need to come under FDA jurisdiction. The unit within the FDA that will consider this particular technology is known in short as CBER, or the Center for Biologics Evaluation and Research. And in their lingo, IVG will come under the so-called HCT/Ps, which is human cells, tissues, and products. And the person who will likely deal with this is a certain Peter Marks, Harvard-trained MD, PhD, who is currently the head of CBER and is in the center of any and all clearance of any biologic product, any medication, but also, of course, any advance along these lines. Which takes us full circle to the Nuffield Council on Bioethics and on the placement of in vitro derived gametes at the top of the list. So the day of gametes to order may be coming. For the time being, I would say, stay tuned. Thank you very much.
Thank you very much. A brave new world indeed. Lots of things to think about. I was curious. I mean, it seems totally not ready for prime time, but very exciting. But if you were in the IRB for the company that's applying for clinical trials, what would you think about or ask?
Well, the company really just requested to do what we call phase 3 clinical trial. And what they exactly have or what they presume to do, of course, they keep secret. It's a commercial enterprise that intends to make money. They attended the national workshop I chaired in 2023, but didn't say much. It just informed people like me that this has moved from the Ivy Towers to private equity and to Silicon Valley. They don't show us their cards. We don't know what they have. And the FDA, even though we inquired, is prohibited from sharing any information on what they plan to do. So we remain in the dark is the bottom line. But the very fact that a commercial enterprise is applying to the FDA for a phase 3 clinical trial permission tells you that they are almost ready to go. They can't do it without FDA approval. And you can't get FDA approval without FDA-approved clinical trials. And so they are embarking on what will be a long road, at the end of which they may be in a position to market their product. So to us, this is somewhat of a new development. But as I said, in the paper we just wrote about IVF and induced pluripotent stem cells, it was influenced by the fact that commercial entities are entering the fray. And we can no longer just discuss our friends from Japan, who are doing this, as best we can tell, just for science. So in the good spirit of the US of A, we are moving forward to commercialize in vitro gametogenesis.
Very exciting.
Thanks for a terrific talk. You argue cogently that it can be done. You suggest it needs the FDA approval. I guess I'd argue that it will be done. There are lots of islands around the world and places where people can gather and do things without FDA approval. And I'm curious, in 2023, when you gathered the group together, National Academy of Medicine, how much time you spent talking about whether it should be done and what salient ethical issues you identified in an individual creating two gametes from themselves and having a child, or this technology being out and about, what we should be worried about, not from the technical aspects, but from the moral aspects of undertaking it.
Without getting into the weeds, I would say, and this is available in book form and also I think probably still online, the prevailing sentiment was care and supervision. Take care and don't let this get out of hand. We don't want to be in the Wild West of in vitro gametogenesis. It's a powerful technology. It's liable to be abused. And we want to keep a close eye on this as much as we can. Individuals with legal backgrounds spoke on this very topic. Ethicists from various institutions spoke to that effect. And as I mentioned, Dr. Marks was there to emphasize the indispensable role of the FDA in making this a reality. So we need to proceed by the book, carefully, gingerly, ideally not to over-commercialize, but of course that's impossible. But if we are to commercialize, let's do it in a way that is responsible and to the degree that's feasible, have it deliver added value to the well-being of humanity. In this case, to the well-being of infertile women who are undergoing IVF. I think the promise of the Silicon Valley company is to provide somatic cells to mature gametes in vitro and thereby spare, quote unquote, the prolonged gonadotropic stimulation that women have to endure in IVF. Since they don't say much more and you can't really penetrate their various defenses, I think that's a reasonable conclusion to draw from what they'll likely be sharing with the public once they are FDA approved. I would be surprised if anything shows up on the market anytime in the next 5 years, maybe 10 years. But for people like you and me, who are in the business of reproduction, and in some cases in the business of infertility and reproductive endocrinology, I think it's important to be cognizant what's coming down the pike. And this is coming down the pike, like it or not. When? I don't know. How? I don't know. But this is a powerful technology. It's difficult to envision a future without this technology having been put to use in some form or another. So it is for that reason that I speak about it today, even though clearly it is of little practical value to any of you, no matter what stage of education you're in, because the technology has yet to mature, not to mention be cleared. So we've all been forewarned, I guess is perhaps the best way to put it. And when and if this comes down the pike, we will not be surprised.
There's a question in the chat. I'll bring the microphone back. Insightful talk. In the event that this moves forward, what surveillance systems for safety, i.e. SART type and long-term follow-up registries, do you consider regarding safety and efficacy?
It's a little premature, I think, to deal with that, but this has to be of value. And I think shortening the IVF cycle is, I think, a meaningful advantage. Whether or not it will reduce the price, as I said, is an uncertainty. But anything we can do to simplify the process, I think, is helpful. The demand for IVF is at this point outstripping the availability of clinics and physicians, even though it's a huge enterprise in the US and elsewhere. But you have to wait, and when you finally enroll, it's not a trivial process, let alone an affordable process. In very few states, 16 to be precise, have a state mandate, which helps, which means that most Americans still have to pay the full freight So I think IVG is just part of the inevitable progress of humanity. It wasn't intended to be this way. I think when Dr. Saito and Hayashi began their work, they weren't thinking IVF or any practical applications. They probably still don't. But absent their contribution, and it's a sad comment, I would say, on American science. In the National Academy of Medicine workshop, the only science was really Japanese science. There are no American groups today who work on IVG other than perhaps the commercial enterprise I mentioned. The Americans who attended the conference talked about everything except the biology and the science. So, for whatever reason, this has not taken off in the United States. And therefore, the basic science element of it remains a Japanese enterprise. And I have nothing but the greatest respect for the individuals in question whom I had the privilege of meeting in person over the years. And I have little doubt but that we are in for more surprises, more advances, first-class science in the best of journals.
Thank you for a really interesting talk. For, if or when this is employed in kind of humans, I guess we are concerned about the well-being of the offspring derived from IVG. Have they commented on any implications in the animal model of kind of shortened lifespan or increased incidence of cancer that we would be concerned about?
No, but the question's obviously very appropriate. I have little doubt but that it will come up when it comes in front of the FDA. I don't know that there's any a priori reason to suspect unforeseen pathology in the offspring. But since there's nothing more important than the offspring, the whole exercise is about the offspring, we have to be absolutely positively sure that no harm will be done. But as we stand here today, I am not aware of any ill effects. Of course, there were no pregnancies to speak of, not even in the rodent. But no question that this should be top of mind and never be overlooked, always kept in front. And I'm all but certain that this will be the case.
There's a question in the chat. How close are we to an artificial in vitro uterus? I know you mentioned that a little bit.
Yes. Well, this is perhaps our next lecture, Jeff. This is known in jargonian terms as ectogenesis. And there is a huge literature on ectogenesis, but not a lot of it is communicated to the individuals who don't have, shall we say, a first-hand interest in the possibility. Let's just say two things. One, it hasn't happened yet, not even in the rodent. But some of the most excellent scientists in the world are working on this very issue. And I suggest that we keep our eyes on the Weizmann Institute in Israel in particular in this context. So nobody really has taken it to a level that is practical in any sense. And then, as I alluded to earlier, whereas I don't see any objection on the part of men or women to IVG, because I think it is a sensible way of shortening IVF and helping out in other contexts. Keeping gestation, which is what OBGYN is all about, right? Is this something we can vote for? And when I say we, I'm not even eligible to vote. It's the women who will have to vote. And yes, there's no question when I speak to my wife, for example, we have all kinds of mixed memories from the birth of our son, but which, by the way, was born at the Lying In at the time. But at the same time, it is definitely part of the human experience. So far is it for me to speak on behalf of women, but I think that's where the answer lies.
Any other questions? There's another comment in the chat. This lecture was incredibly timely, so very interesting. Everyone in our world will surely be affected by this research. We're so very grateful. Thank you for your vision. Just complimentary, no question.
That's the Breed family. Thank you for your
Oh,
participation.
okay.
Thank you.
Thank you so much.
Thank you all.
Thank you so much. It was fabulous. Thank you to the Breed family as well.
And many thanks again to the Breed family for their support of this lecture.